Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is 1663 smallest string with a given numeric value. So basically what we're trying to do is using all the letters of the alphabet from A to Z, try to make of length 3, and that's the smallest lexicographical order. And the target sum is equal to k. So 1 plus 1 plus 25 is 27. So before we do anything else, let's go ahead and make a dictionary and let's get all the letters of the alphabet. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. W, X, Y, Z. Cool. So now let's go ahead and try to make this requirement. So A starts at 1. So for I in range 1 to 27, because 27 is going to be up to including 26, so 26 letters. And we're going to set I to letters I minus 1, because I starts at 1, but A is 1. So A is at index 0, so that's why it's 1 minus 1 is 0. So if we print D, cool. So now we've made what we need. We've finished this requirement, so let's go step by step. And then after that, what we're going to do is try to make K. And the whole idea behind this is if we currently, the reason we can use A is because if we add the difference, how many other turns, if we fill the rest with Z, if we have 3 turns here, can we still make the target of K? If we can, then we can pick A. Basically, we want the smallest number where if we fill the rest with Z's, aka 26's, then we can still be on track to our target of K, because we don't have all the rounds left. We only have 2 turns left after the current turn. So hopefully that makes sense, and so that's what we're going to do. So while n is bigger than 0, we're going to say we need k, right? And at this point, let's go ahead and make a sorted list. So let's call this val. And for, let's go ahead and make a sorted list of keys. So for 1 to 26. And then for S and SL, again, we're going to ask the question if S plus, so the current key 1 plus, and n is going to be, difference is going to be n minus 1, because that's how many other turns we have. If difference times 25 or 26 is bigger than or equal to need, then we can actually add S, right? And then in that case, at the end, if val, meaning if there was something that exists, let's go ahead and print value. So if value, then need minus equal to value of 0. And okay, so let's get rid of this to make this more clear. But basically that's the idea. And so need is k, and we're going to subtract val of 0 from need. Okay, so you're going to see 1, 1, and 25, which is great. That's exactly what we want. Here, 1, 1, 19, which is S, ZZ, 26, 26. So exactly as I said, because again, for this example, as we're going A, if we fill the rest with Z's, we can still get on track. It's bigger than or equal to the difference we need, which is k minus however many we've used up to the current turn, right? There are n turns. So in that case, we can go ahead and make an answer. And so we can just say answer plus equals to d of val of 0. So that's going to be the letter itself. and then we can just return answer at the end, right? So let's run this. Okay, submit it. Output limit exceeded. So let's do this again. Okay, time limit exceeded. Really big numbers for n and k. So that's good. That means our formula is working, but we're trying to find the s that at least makes this difference and is the smallest s can be. What does that tell you? It probably means we can run a binary search. So let's start from 1 and go up to 26 because that's our search space, right? We're trying to find some value in here that satisfies this equation if we plug in that number as s. Because the rest, if we fill the rest with z's, we should at least be able to make whatever we need, right? So let's go ahead and do that. While left is less than or equal to right, mid is left plus right divided by 2. And because this is already sorted, so we can run a binary search and try this. If it's not good enough, then we can go here. If it's too good, then we can go here. We're going to keep minimizing as much as possible as long as the equation is satisfied. So if mid plus mid is s plus whatever our difference was times 26 is bigger than or equal to need, then val.add mid and shrink our right pointer to throw away the right half because we're looking for a smaller, aka better result. Otherwise, if it's not satisfying the equation, then we can throw away the left half because anything less than this doesn't satisfy it, right? Okay, so now let's go ahead and run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.